cool. And we want to make things even better. I'm going to add a little bit of security. The NetOps team have said, this is great, but every service can talk to every service, and that shouldn't be necessary. So I just want you to turn on the RBAC system, do a few ACLs, a bit of service-to-service security. So this is where the demo starts, and I have to work out my So we're going to go turn on RBAC. I have another TMUX session attached on this screen, so I think this is going to work. Yeah. OK, so I'm going to turn RBAC on. No magic here, right? We apply a config that says, there are no tricks in this demo, honestly. So we're turning the RBAC system on. My script was designed for Istio 1.4. It's using a new command that waits for the propagation of resources across the mesh, because the RBAC system is a little bit eventually consistent. You'll see if I start hitting F5. I can't see my pointer. That things are going to start. There we go. So we just got a 403 on the CSS. Right, and the RBAC's on. So the only error we saw on the terminal. Oh, you can't. I'm highlighting things on this, and it's not coming through. But the invalid character is just It's just a Istio CTL command that relies on a 1.4 Istio mesh to watch for this propagation and to sort of let you block on it. But I'm running a 1.3 mesh because there were some other issues. But don't worry about that. There are no tricks. So everything's blocked. Great, because we turn RBAC on. Sensible security stance is to block everything by default. So that's exactly what it's done. So now I'm going to go and add my rules to allow the RBAC. Again, this is just the standard book info demo that I'm using here. So we're adding 3 service roles and 3 service roles bindings to allow the communication that we want from service to service to open things back up and make the application work again. And it takes a while, and kinda. If everybody remembers how Bookinfo works, we've got the product page. Microservice gives you this overall view, but it calls details to get the top or the left panel, and then it calls reviews to get the bottom or the right panel. And we can see product page, but we can't see details or reviews. It's just erroring out, right? Product page is got some code that says, well, if you can't reach that service, show a default value. In this case, I'm sorry, I can't get you that information. We're trying to gracefully degrade, but we're running in a degraded state. So what's going on? Why can't we get there? And this is analogous to the problem that I had. Oh, man. I've got another meme. Yeah. Somebody posted that in Slack after about 3 hours of my swearing. I was like, I'm going to lunch, and I came back to find that. So we're in the bad place. It ain't working. I was going to run this like a sort of on-call session. I was going to pretend we had this 30-minute SLO to get things back up and have a countdown timer and a red light and a klaxon. But you can't take that shit in hand luggage. So just I'm going to keep looking at my watch. Imagine we're under a bunch of pressure. I also said I'd kind of talk about debugging principles more generally. And as I say, the time's a bit tight. But I know not everybody has a software engineering background, or people who have a systems background maybe aren't used to distributed systems like this. And this isn't typical software anyway. So I'm going to throw out a few things about debugging. Number one is this phrase that was told to me by an old manager that I really liked, which is, in order to debug something, you've got to be able to observe it, and you've got to be able to control it. So that observability, right, is the ability to sort of work out the internal state of the system only by looking at it from the outside, right? So what we know at the moment is we're putting traffic in, and we're getting an error out. So we know we can observe that. We know something about it, but that's not enough to work out what's going on in this box so we can actually go fix it. So what we're going to do is we're going to get some more outputs from this. Basically, we're going to turn logging up, right? It's not rocket science, but if you think of it in a more abstract sense, I need to see into this system to work out what's going wrong. Product page is telling me it's had to degrade. What on earth? So the first thing I need to do is, this is probably an RBAC problem, right? It's probably responding to a 403, but hey, maybe the details and reviews just crashed or something. Maybe it's a coincidence, who knows? First of all, I want to check that this really is a 403, an RBAC problem. So let's just go look at the traffic. So I can run this command. It's a bit of complicated Helm wrangling, but it basically rewrites the master config map that Istio uses to look at everything, so config map / Istio, and we're turning on access logs in Envoy. We're writing some config that gets propagated through a complicated series of mechanisms to the Envoy sidecars and tells them to just start dumping the access logs, because they don't normally, right? At 1,000 QPS, that's going to be super noisy, so it's turned off by default. So we turn that on, and we sort of let it think about it for a bit. And then we can go get the logs. So these are the logs. What I'm going to focus on is details, so product page calls, details and reviews. We're just going to look at details, that top service for the whole thing, because it's not giving product page what it wants. So we'll just dive into details. So we got a bunch of noise in here. Again, no tricks, like there's nothing really sitting there. But if I start generating some traffic, there we go, there's an access log. A lot of these systems are, they log on a background thread, they get off the hot path, they butter things on a background thread, they batch them. A lot of these systems are designed to be very high performance and very latency aware, which means that actually getting the logs out often involves me just pressing F5 a lot and waiting, right, to fill a buffer or something. But as you can see, you can kind of read this if you've ever seen an Nginx access log. There's a 403 in there. So this is the Envoy sidecar by details saying, yep, I saw your request, but no, you are forbidden, go away. Debugging tool number 1, you can turn on Envoy access logs, and you can just read the logs of the sidecar container in that pod, and you can get them. That's a bit hard to read, I think. This is some text format. It's not a structured log. It doesn't have any field annotations. I do actually have a picture. Somebody on the internet helpfully put this together. I mean, it's fairly helpful, right? I mean, I'm not going to lie, the production values are fairly high. So we can see, I didn't draw it, I can't draw that well, but the response code should be a 200, it's a 403, right? We got a problem. So, first tool, OnGuard. There is a little tool, and it's called OnGuard, and it's basically an Envoy access log parser. So you cut the command scrolled off the top. I can probably go find it. Yeah, so kubectl logs, the details pod, the Istio proxy sidecar, and then pipe to this OnGuard thing. So OnGuard basically parses it and dumps out JSON, and then I'm piping that into JQ to get some nice pretty printing. Obviously, because it's JQ, you can query this thing, you can extract certain fields, you can take aggregates, blah, blah, blah. Anything you can do now, you've got this structured JSON, and we've got a schema for it because we know all the fields that are in an Envoy access log. So there again, same information, but with more colors, status code 403. So, okay, what next? I'm going to do the same thing, but I'm going to do it more gratuitously because I want to show you another cool tool. That cool tool is called ksniff. So it's not quite the same thing. That was an access log. Let's really dig in. So Envoy's saying 403. I mean, there's a slight possibility that details has started to respond with a 403 itself, and Envoy's just forwarding it, right? I mean, it's unlikely, but it could be a thing. And there's a bunch of other reasons you might want to actually look inside the pod properly. So remember, a pod is all the containers share a network namespace, so there's sort of one set of routes and IP tables rules in there. All the traffic flies around freely between all the different containers. So if only we could tap into that, it would if this were a Linux machine in the 90s, I'd shell into it and I'd run TCP dump, right, to find out what's really going on. Turns out you can do that. There's a tool called ksniff, which is a kubectl plugin. So things get a little bit interesting because you use crew, which is the kubectl package manager, which is itself a kubectl plugin, to install a kubectl plugin called ksniff, which does a whole bunch of shit. It's come up on the wrong screen. Oh, no. OK, hold on. Basically, it shells into your sidecar. It runs TCP dump. It sets up a port forward, and it dumps the PCAP output of TCP dump into Wireshark on your local machine. So this is a live traffic capture of everything that's going through that pod. I can't see it, so I'm going to have to bring it back. And I'll point out things like right? Something is getting /stats/Prometheus, right? So something scraping the Prometheus endpoint is getting a 200. Fantastic. All the traffic going through the pod. I can apply a filter. Generate some more traffic, and there we go. I won't dig into that because honestly it's too hard, but those are your 403s, and you can dig in obviously and get all the layer 2, layer 3, layer 7 information. Your full Wireshark, you can write these very expressive filters. You can do all kinds of stuff. It's super cool. It's a sort of slightly shinier version of what we did before, but it's awesome, so I wanted to show you it. I am going to start swearing, honestly, right? So it's all meshed up. We're getting 403s. What the hell? Don't understand. Need to find out why. So what about the controllability side of this thing, right? Can we go into the system and affect what it does? Because we want to start running experiments. Like, we kind of know what's wrong. We want to start tweaking dials. We want to see if we can control it and get it closer to the right thing, or if we can break it in a different way or whatever. So it's a 403. We think it's Envoy producing it, not the app. It's a reasonable hypothesis to think that that was because we just turned RBAC on, right, and it's starting to deny traffic. So what can we do to test that? Well, we can turn RBAC back off and see if it works. It sounds stupid, but that's basically what we're going to do. We can actually do a little bit better. There's a permissive RBAC mode, so it's like SE Linux permissive mode, if anybody's seen that. We can basically say to the RBAC system, I want you to still look at the traffic, still ingest all the rules, still understand the rules, but not enforce them. So I want you to log what you would have done and why, but don't actually enforce them. So that'll kind of kill two birds with one stone. So I can now put RBAC into permissive with some logging. Again, there's a bunch of esoteric config for this. The book info sample even comes, and this is why I'm using book info, because I had to work all this out myself. The book info sample comes with a couple of YAMLs. One that puts RBAC into permissive mode, and one that turns on all of the permissive mode logging. Having turned it on, we can read it. This is where you sit there and I press F5, because Mixer aggressively batches. So you can see it's starting to work again, right? Traffic's come through, so pretty much 99.9% that was an RBAC issue. Traffic's going through again, but we're now in permissive mode, so if we can finally fill that buffer. There we go. And they all come through at once because we're in a big batch. I've added some highlighting. So these are Mixer logs. These are structured. These are JSON. So at a warning level, we've got it says, well, your response code is 200, but the permissive response code, as in what I would have done, is deny. So this absolutely is an RBAC deny coming from the sidecar. But this is about that kind of controllability, right? I can take the RBAC. I think it's the RBAC system. I can turn it on. I can turn it off. I can put it into a verbose mode. RBAC decisions are enforced at, RBAC policy is enforced at the sidecar, but the decision is ultimately made by Mixer currently, for anybody who kind of knows the Istio architecture. So it's the Istio pod logs that we go and look at. iTerm just asked me if I want to upgrade, because you should never do live demos. Right, so this is my reminder, because I always forgot to do this in the run-through. I need to turn the RBAC back on, so I need to actually make it fail again if we can carry on debugging. But this is under the broader spectrum of only change one thing at a time, right? This is the scientific method, really. You change, well, you have a hypothesis, you change one variable, you go and see what it's gone and done. So I thought I only changed one thing when I turned RBAC on, and everything stopped working. So it was a reasonable hypothesis that it was RBAC that did it. We've now definitely only changed one thing, because I'm like, right, I'm in debugging mode. Let's just turn RBAC off and not touch anything else. Oh yeah, that fixed it. Right. So what we will do is just go and turn RBAC. I'm just going to use that original script and just dump the RBAC on config over the top. So it's RBAC. Let's look at how that subsystem works, right? we need a mental model for this system, and we just need to follow it through logically. So how does the RBAC system work? Well, from what I know of Istio, there's some rules. We apply the rules. Pilot reads them. Pilot sort of interprets them and compiles them into Envoy config. Pilot pushes that config to Envoy. The envoys receive it and ingest it and understand it, and then they enforce it. Something's going wrong at that stage because I have given Envoy instructions to let this traffic through. Envoy is not doing that. So one of these stages has gone wrong. That's why I should have drawn a picture of it, but that's my mental model of my pipeline left to right. So we can start at the left, and we can just go check each one of these components. And that's exactly what we're going to do. So 33. So the first thing we can do, there is another magic Istio debugging command to learn. All of the control plane components are built from like the same microservices library. They all listen. So Pilot, Mixer, Citadel, I think, and Galley. They all have a web admin port. They all have this high number port where they expose a web admin interface. So you can configure them obviously with command line arguments and config files, but they have an online admin interface as well. Istio CTL dashboard is a nice shortcut that basically sets up a port forward to that admin port, right? So it's all kind of nice and easy to be operational. Remember, you're probably going to be doing this at 3 a.m., right? So these are just tools. There's automation really rather than abstraction, but all this is doing is setting up a port forward to the admin port. So we've got the Pilot admin port. It's actually a fairly nice web interface, like it even updates in real time. And there, I can't see it, but there's a bunch of stuff we can do, a bunch of stuff we can read. And I think it's that one. One of the things I can do is turn logging levels up in various places, and I want RBAC, which is 2 up. So I can change that from info to debug. It's very Web 2.0. There isn't even a save button, so that's done now. So I've now turned the RBAC logging up because I know that I'm ingesting my RBAC config, and it's trying to compile it, and it's going wrong. So let's look at what it's thinking when it does that. So what I'll do is just to kick the compiler, I'll remove those RBAC rules, the ones that say allow the traffic, and I'll kind of wait a bit. Then I'll put them back. Now that the logging is turned up, and then we can dump the pilot logs. And again, I put a little bit of grep magic in there, so you can see listener discovery service. So this is the thing that sets up the front end of Envoy and tells it to listen. Is indeed pushing some config to the sidecar by details. Oh, and that's not the problem. I don't need to scroll that way. I'm surprised that's all the logs we've got. Let's do it again. Oh, there we go. That looks more like it. Okay, we might not get exactly what we're looking for because it's a little bit. Oh no, there we go. So the RBAC subsystem says, right, I'm going to go. I'm compiling all your RBAC rules. I'm going to go build a policy. This is for details. So I'm going to check the service role called ratings viewer. So that's the one that gives you permission to view ratings and details. And oh yes, I've added something to the Envoy policy for that, the Envoy RBAC policy, because this ratings viewer Istio policy had something to say about it. So we've definitely picked up the Istio config that we want, and we've added it to this RBAC, this Envoy RBAC that we're building. And then it looks at the one that lets you view product page and says, well, that's not relevant to this details sidecar, and then skips it. But eventually we build the HTTP listener, and these are all multiplexed so that we can't really see the push to details on this page, but that's how it's working. So we can reason about this kind of compilation process for these RBAC rules. So that seems to be working. So let's go further down that pipeline, right? We've started with something that seems to be working. Let's follow it through. And I'm going to speed up a bit, but I think I'm doing kind of okay. So proxy status, Istio CTL proxy status, very useful command. did Pilot manage to push and sync the config into all of these pods? It says yes, it did. For the sidecar on details, which is the top of the list, cluster discovery service, which is basically the back ends, the things it might want to talk to, listener discovery, which is the thing on the front end, endpoint, which is also back end stuff. Anyway, all of the different parts of the Envoy config service, the Envoy config space, are all synchronized. So okay, we built a policy that we assume is correct. We pushed it to the envoys. What can we do next? Well, let's look at Envoy. Envoy also has its own web interface. It's more Web 1.0, to be honest. It's a bunch of links that just do GET requests. But it is there. And again, there's Istio CTL dashboard command that will open that up for you. I won't show you around this because we're running a bit short on time. If you ever want to know how complicated Envoy is, press the config dump button and count the lines. Honestly, count the lines. But because it's a bit dumb, unfortunately, to turn the logging up, you have to do a post request, and you can't do a post through this web interface. So we actually have to close it and then kill that pull forwards. And actually just set up the pull forward ourselves. We have to basically exec in and use curl. We have to hit that endpoint ourselves because we have to do a post, which we can't do with a browser very easily. And the output, the body that returns in response to that post is the current state of all the debug, all the tracing areas, including, you can see it there if you can find it, just below pool, just above Redis. RBAC is now on debug. Everything else is warning. Which means, again, I can read them with a nice Istio CTL, kubectl logs command for that detailed sidecar. You can see all the stuff it was printing at a warning level before, the access logs that we were talking about. But now, if I generate some more traffic, it should be really verbose about what it's doing with RBAC. It's easier to read on my screen. So RBAC comes in. Request comes in, path is details 0, the details of the 0th book, or your standard HTTP headers. So this is the set of metadata that Envoy has about this request, and you can make policy decisions based on any of that, right? What we're looking at is the service that's calling it. So we're not blocking things based on user agent, we're not blocking things based on port, we're blocking things based on who's trying to talk to you, because this is service-to-service ACLs, right? We're saying that product page can actually make any request to me, but it's only product page that's allowed to talk to me. So you can see that the metadata includes all the HTTP headers. It also includes a few pieces of dynamic metadata, a few things that aren't from the request that have been enjected by the environment. So Istio has a bunch of plumbing to give it more information about the request. One of those things is Istio auth-n, as in authentication, the name. So we have this key, Istio auth-n, who's talking to me, but the value's empty. And then it says enforce denied. So that's a bit weird, right? How do we know that it's product page talking to us? This seems like the kind of information we should have to hand, because we know if we'd had time to open the service role binding, we know that we've said, well, it's product page that can talk to me. So there we go, enforce denied, and then the access log 403. So here's one last piece of debugging advice, guess and check, right? You have a mental model. All models are wrong. Some models are useful. Take a plausible hypothesis, right, that fits within that model. And this is a creative step. This is why debugging is draining, and you can't estimate how long it's going to take. But you take a creative step to a plausible hypothesis that makes sense in that model. You design an experiment that's going to check that and check only that. And ideally, your experiment wants to only change one thing about the system at a time, right? It's standard scientific method stuff. It gets super hard when your model is wrong, right? Or when you have to run multiple experiments, you have to change multiple things, and you're trying to infer one answer. It can get super, super hard. But guessing and checking in general is a good idea. So we don't have this user account. We don't have this name for who's trying to call me. Well, where's that going to come from? If you think about how you bind a service role, you give it a service account name. It's not the name of the calling service or pod, because you can't really do that. The only strong identity you can trust is the service account token, because the product page pod has the product page service account token on the file system, so its Envoy can lift that off the file system, send it across the wire, and this thing is cryptographically signed. You can send that up to the Kubernetes API server and say, hey, does this JOT check out? Is this signed in the correct way? Can I trust the claims of identity that are in it? So we seem to be missing that. I don't know how to word this next bit, because if I say too much, I'll give it away. And I want a big reveal, because we like a big reveal. But, you know, maybe it's something to do with the way two services talk to each other, what's on the wire. Well, let's check. Let's analyze that config. Istio-CTL experimental analyze. -K means go look in the cluster. You can point it at a bunch of YAML. It'll check whether it's consistent. This reads everything out of the cluster. No validation errors found. So I say debugging gets really hard when your model or your tools are wrong. This tool is wrong. This tool is experimental and wrong. It's not wrong. It's just not completely right. It's not lying. Anyway, fuck it. So let's look at the two sides. It's the product page pod. It's calling the details service. So Istio-CTL experimental describe, the product page pod. Well, okay, it listens on port 9080 and then out the back. Actually, that doesn't really tell us anything useful at all. But the details service listens on 9080 HTTP. It's permissive insofar as it'll accept HTTP or MTLS. And the clients will speak to it over HTTP. And it's found an RBAC policy. There is an RBAC policy that applies. That's that reviews viewer that we saw being compiled. So like, client stalk HTTP. So details is a server that will accept MTLS or HTTP, and its clients are talking HTTP. So MTLS is turned off in this cluster. Let's secretly fix things. And find a mouse pointer so that my correct timing works. Oh, look. I turned MTLS on because the way it gets that identity is it picks the service account token up off the file system and it uses it as the common name for the MTLS certificate that it presents. That's the only thing you can really trust. You can't just look at a source IP because that can be spoofed. There's no way to get the name. So in order to know which pod's talking to you, there's an MTLS certificate on every side, and the identity of that, the common name, is the name of the pod. And that is verified by the Istio agent, taking that service account token, talking to the Istio control plane to Citadel and saying, right, I have this. If you trust that this really is the identity of my pod, can you please mint me a TLS certificate that's got that name in the CN? And then those things are used for MTLS. So it not only gives you encryption on the wire, it gives you a strong claim of identity on both sides that's tied all the way back to the workload and its identity, which is the Kubernetes service account. So what we were doing was comparing, as we saw, comparing an empty string against product page because there's no MTLS, so there's no common name on the wire. And that is, I basically misconfigured this. I put it into a configuration state that's inconsistent, and therefore it was trying to enforce RBAC, and it was just failing safe and saying, well, these names didn't match, denied. So now it's working, and we can go back and look at the Envoy logs. The RBAC logs are probably the most interesting. You can probably already start to see it. So Istio auth-n, suddenly a bunch of values in there, right? It's not empty. We've got a couple of source principles, authentication principle, cluster.local, default namespace, product page service account. And magically it works. So that was the problem. Why are we allowed to get into this seemingly inconsistent state? Well, you can actually enforce policy based on end user identity. You can enforce policy just based on other metadata like the port or the user agent or something. So it is okay to try to enforce RBAC with MTLS turned off, but if you actually want to do by far the most common case, which is service-to-service auth, then you're going to need MTLS on to get that identity across the wire. Fine. So, and it's not the greatest config surface ever, but they do allow, it's just as flexible as it can be. It does allow you to do those other things. As I say, Istio-CTL analyze says, well, there's nothing wrong with your config. And besides, service role and service role binding are a little bit clunky to work with, and they're going in 1.6 anyway. They've been replaced by by authorization policy. So that was it. I just lost a day to it, but I went through that whole set of tools of the learning where all the logs are, learning how to turn them up, those two web interface dashboards, and all the super cool traffic dumping stuff. So hopefully that was interesting and enlightening. And yeah, that was all I really wanted. Oh, one more debugging tip is to basically not panic. I was going to have a klaxon. But I mean, seriously, stress doesn't help. Shortcuts don't help. You've got to be methodical. You've got to be scientific. Like, you don't speed yourself up by panicking. You don't speed your team up by shouting at them. You speed it up by reducing cognitive load. Like, having those scripts that I used, those should be scripts that you have, or they should be in your runbook so you can copy-paste them. And you can reduce typing time and error by just having that. Like, don't abstract things to oblivion. Just automate them. Keep calm. Have runbooks. Have practiced. And use shiny tools. Thanks.